Welcome to the DX Today podcast, your daily deep dive into the AI ecosystem. I'm Chris, and joining me as always is Laura.
Thanks, Chris. And today we are covering something genuinely seismic. Google held its annual I/O Developer Conference in Mountain View yesterday, and the theme was not incremental updates. It was a full philosophical pivot toward a world where AI agents, not human developers, do the orchestration.
When you say orchestration, I want to make sure we are grounding that for people who are not in the weeds of developer tooling, because that word gets used a lot. But what Google announced yesterday has a very specific meaning that I think is worth unpacking before we dive into the individual products.
Google's framing was one of the clearest statements from any major tech company in years. They transitioned from AI that simply assists you to agents that independently navigate complex tasks across your entire workflow, and that is a technical declaration of intent, not marketing copy.
So the old model was developer writes code, AI is a smart autocomplete beside them. The new model is agent takes the task description, plans the work, writes the code, runs it, verifies the output, and hands back a result. A human audits after the fact. I think the phrase independently navigate is doing a lot of work in that sentence too, because it implies the agent is not just executing instructions, but making decisions about how to proceed when it hits an obstacle, which is qualitatively different from what most people picture when they hear AI coding assistant.
And what made the announcements compelling is that every product maps onto a specific stage of that pipeline. Gemini 3.5 handles the intelligence layer, Antigravity 2.0 handles execution, the Managed Agents API and SDK handle deployment, WebMCP handles browser interaction, and the Android CLI and skills handle mobile development.
Let's start with the model itself because everything else depends on it. And Gemini 3.5 Flash is the headline model from yesterday. So what is actually new here compared to what Google had before? And how does it compare to what the competition is shipping right now?
The standout number is that Gemini 3.5 Flash outperforms Gemini 3.1 Pro on almost all coding benchmarks while running 4 times faster than other frontier coding models, and speed in an agentic context is not a convenience. It is a cost multiplier that determines which tasks are economically viable. The fact that Flash rather than Pro is the flagship for coding tells you something about where the field is heading. Because Flash used to be the lightweight option you traded down to for cost, and now it outperforms what was the heavy flagship, which suggests the efficiency curve is moving faster than most people anticipated.
That 4 times faster number compounds in an agentic context because an agent running dozens of tool calls accumulates latency on every step. So a model that is 4 times faster is not just more responsive. It makes entirely different classes of tasks economically viable that were previously too slow or too expensive.
For context, the previous Gemini 3 launched in November 2025 and hit a 1501 ELO score on El Marina and 76.2% on SUE Bench Verified, the standard benchmark for coding agents, so Gemini 3.5 Flash is building on a foundation that was already at the top of those rankings.
Now, Antigravity 2.0 is the environment where this model lives, and I want to make sure people understand that the Antigravity is not just an IDE, because I think there is a temptation to hear the word and think VS Code with an AI plugin, but the architecture is genuinely different from that. The benchmark specifics matter because SWE Bench Verified measures whether an agent can take a real GitHub issue and submit a pull request that actually fixes it. So a 76.2% score means more than 3/4 of real software bugs are being resolved autonomously.
Right, because the original Antigravity launched in November 2025 was already agent first, with a main editing surface and a separate manager view where agents work asynchronously, and version 2.0 separates the product from its previous IDE-only form into what Google calls a unified harness with 2 complementary surfaces.
You have the graphical application on one side and a new anti-gravity CLI on the other, with the same agent runtime underneath both. So a terminal-first team gets identical capabilities to a desktop team, which removes the surface area argument from enterprise procurement conversations.
And the multi-agent piece is worth dwelling on because Antigravity 2.0 introduces what Google calls specialized subagents, meaning you can spawn multiple agents to handle parallel parts of a workflow simultaneously rather than running everything sequentially through a single agent, which changes the economics of complex software projects pretty dramatically when you start modeling out the time savings. The CLI equivalence point is actually a bigger deal than it sounds in the announcement, Because historically, when companies release developer tools, the graphical version gets the polish and the command line version is a second-class citizen that lags behind. And Google is explicitly committing to parity, which makes the CLI trustworthy enough to build automated pipelines on top of without worrying it will fall behind.
That parallelization capability raises some obvious security questions. Because you are now talking about multiple AI agents simultaneously accessing a terminal, a source control system, and a file system. And I am curious how Google is thinking about the attack surface that creates when things go wrong or when an agent takes an unexpected path.
They address this directly in built-in cross-platform terminal sandboxing, credential masking, and what they describe as hardened Git policies. So the intent is to give agents enough access to be genuinely useful while preventing the obvious failure modes like an agent accidentally pushing credentials to a public repo or overwriting a production configuration file during a refactoring pass.
Beyond the desktop and CLI surfaces, there are two other deployment shapes that I think got a little less attention in the coverage, but are actually quite significant for how enterprises are going to adopt this, which are the Managed Agents API and the Antigravity SDK. The subagent model also changes how you think about code review. Because if multiple agents are working in parallel on different parts of a feature branch simultaneously, you need a coordination layer that understands dependencies between their outputs. And Antigravity 2.0 appears to be positioning itself as that coordination layer rather than just the execution environment.
Together, those options mean the same agent stack is available in 4 deployment shapes: desktop application, terminal CLI, hosted API, and self-hosted SDK. Exactly the flexibility enterprise procurement needs before a platform can clear a security review and reach production.
And then the Antigravity SDK is the opposite end of that spectrum, aimed at organizations that need to run agents on infrastructure they control, whether that is because of regulatory requirements around data residency, internal security policies, or just a judgment call that sensitive intellectual property should not flow through a vendor-managed sandbox.
The Managed Agents API is elegant in its simplicity. You make a single API call and get back a fully provisioned agent with a remote sandbox already attached, no infrastructure setup required, which dramatically lowers the barrier to adding agent capabilities to an existing application without a dedicated platform team. Credential masking at the platform level is the right architectural approach because one of the main blockers to enterprise adoption has been the risk that a model inadvertently logs or transmits secrets it encounters in code. And solving that at the harness level, rather than relying on individual developers to sanitize inputs, removes it from the compliance conversation.
Let's talk about WebMCP because I think this is the announcement that has the most potential to change how the broader web works, not just how developers build software. And I want to make sure we give it the space it deserves because the implications extend well beyond the developer audience at I/O.
WebMCP is a proposed open web standard solving the problem that browser-based agents today must take screenshots, parse the DOM, and simulate clicks to interact with websites, an approach that is fragile, computationally expensive, and breaks every time a site updates its visual layout.
So the alternative WebMCP proposes is that websites can expose their functionality directly as structured tools, specifically JavaScript functions and HTML forms that an agent can call directly, rather than having to visually interpret the interface and simulate user input, which is a fundamentally more reliable and efficient way to accomplish the same underlying task. The 4 deployment shapes are also a competitive response to the fragmentation that hurt earlier enterprise AI tool rollouts. Because if agent capability only works in one environment, every team outside that environment is excluded. And making the runtime portable means a single enterprise contract can cover a much wider population of developers.
Google's Chrome team actually launched an early preview program for WebMCP on February 10th of 2026. So this has been in development for several months, and now they are moving to a formal origin trial starting in Chrome 149, which is the mechanism Chrome uses to test proposed web standards with real traffic before deciding whether to standardize them formally.
The standardization angle matters a lot here, because if WebMCP becomes a web standard rather than a proprietary Google API, then every browser and every website and every agent framework has a clear specification to build against. And that creates a much richer and more competitive ecosystem than if it remains a Google-specific interface that only Gemini agents can use natively.
The implication for the web is significant because if WebMCP succeeds, you get a bifurcated web where sites expose both a human-readable interface and a machine-callable one, and agents use the latter because it is faster, cheaper, and does not break when someone redesigns the homepage. There is a market signaling dimension too. Proposing WebMCP as an open standard rather than a Chrome-only API is a bid for cross-browser adoption. And if Mozilla and Apple support it in Firefox and Safari, the network effects become strong enough to tip site operators toward implementing it.
Now, the Android announcements were probably the most technically dense part of the keynote. And I want to make sure we cover them accurately, because there were several distinct pieces that each address a different bottleneck in the mobile development workflow. And they add up to something more significant than any single piece suggests.
The foundational piece is that Google has stabilized the Android command line interface. And the reason that matters in an agentic context is that a CLI can be scripted, parallelized, and orchestrated from a central runner in ways that a graphical IDE cannot. So stabilizing it is the move that makes Android development capabilities available programmatically to any agent or automation pipeline.
And alongside the CLI, they open-sourced what they're calling Android skills, which are essentially prescriptive recipes that help language models execute best practices for complex Android-specific workflows, with the two examples they gave being migrating a project to Jetpack Compose and performing a Jetpack Navigation 3 migration, both of which are notoriously tedious and error-prone when done manually. The fragility problem with screenshot-based agents is worse than it sounds, because even a minor redesign that moves a button a few pixels or changes a CSS class name can silently break an agent workflow, whereas a function call interface either works or throws a clear error, making the reliability improvement from WebMCP potentially an order of magnitude rather than incremental.
They also introduced Android Bench, which is a new leaderboard specifically for evaluating how different language models perform on Android development tasks. And they added open weight models, including Gemma 4, to the leaderboard during I/O Week, which signals that this is meant to be a community resource for comparing models rather than a Google internal benchmark used only to make their own products look good.
The migration agent preview is the most ambitious Android claim. Google says it can take an existing app written in React Native, a web framework or iOS, and migrate it to native Kotlin, with migrations that previously took weeks of engineering time now accomplishing in hours.
That is an extraordinary claim, and they were appropriately careful to label it a preview rather than a generally available product. But even a partial automation of cross-platform migration is enormously valuable for any organization sitting on a large legacy codebase that needs to move to modern Android standards. And I expect this to attract significant enterprise interest even in its current preview form. The Android Bench leaderboard is also strategically interesting because by creating a public benchmark, Google gets to define what good performance on Android development tasks looks like, which means other model providers now have to optimize against Google's benchmark to demonstrate credibility in that space. And that is a subtle but powerful way to shape the competitive conversation.
Before we wrap, I want to zoom out to the strategic picture because I think there's something important happening with Google right now that is easy to miss when you are focused on any individual product, which is that every single announcement yesterday connects to a single coherent vision of what the development stack looks like in an agent-first world.
The coherence is what struck me most because you have Gemini 3.5 at the foundation, Antigravity 2.0 and its CLI for execution, the Managed Agents API and SDK for deployment flexibility, WebMCP for the browser layer, the Android CLI, and skills for mobile, and updated AI Studio as the entry point, and they all fit together without obvious gaps in the stack.
The AI Studio to Antigravity export path removes a friction point that has historically kept projects stuck in prototype mode, because a prototype built in AI Studio can now move into Antigravity for longer-form development without rebuilding from scratch.
The question I keep returning to is how OpenAI and Anthropic respond. Because Google just drew a clear line around the developer tooling layer, and that layer is where developer loyalty locks in over the next several years as agentic workflows move from experimental to standard practice.
The migration agent also addresses a real constraint on Android ecosystem growth, because a lot of mobile talent is locked into cross-platform frameworks like React Native precisely because the switching cost to native Android has been so high, and if an agent absorbs most of that migration burden, the calculus changes for teams that have been on the fence. It is the platform wars again, except The platform this time is the agent runtime and tooling ecosystem, and whoever wins that layer gets to be the environment where software built on AI infrastructure actually gets written. An extraordinarily powerful position.
Google's structural advantage is that it controls Chrome and Android, two of the most widely deployed platforms on the planet, and WebMCP plus the stabilized Android CLI are the moves that connect those distribution advantages to the agentic paradigm rather than starting from scratch.
That's all for today's episode of the DX Today podcast. Thanks for listening, and we'll see you next time.